In this video, we'll talk about alternating series, which is really the one type of series that we can handle when talking about conditional convergence. So there aren't many options for trying to figure out if a series converges conditionally, and when the few that we will discuss here all involve the idea of an alternating series. This is a particular type of series that has not all positive terms. And really that's the one thing we'll be able to handle talking about conditional convergence. So what do we mean by a series being alternating? Well, it's alternating if the terms alternate between being positive and negative. So mathematically, we'd say this as if it's of the form sum n equals 1 to infinity, I don't really care where it starts, minus 1 to the n times bn, where bn is a positive sequence. Right, you could also have alternating series if they're of the form, say, n equals 1 to infinity, negative 1 to the n plus 1, bn, and bn positive, or bn could be all negative. It really wouldn't matter. The point is I need my bn's to have the same sign so that when I go to find this series with this negative 1 term in front of it, it actually goes positive, negative, all the way through the entire series. It's important to realize they have to alternate. It has to go one each every other. If it does anything else, it's not considered an alternating series. It could go, if it goes like 2 positive, 2 negative, 1, 1, 2, something like that, that's not alternating series. Alternating means it goes plus, minus, all in that order the entire way down. So what are some examples of these? Well, we've seen some of these before, actually. Things like negative 1 to the n over n squared, n from 2 to infinity. That's an alternating series because my bn here is a 1 over n squared, and then I have my negative 1 to the n to make them alternate between positive and negative. So right, this series would start 1/4 minus 1/9 plus 1/16 minus 1 over 25 plus 1 over 36, and so on. Right? Every other term is positive and negative. And this minus 1 to the n is a common thing you'll see in these series because that's how you're going to know that it goes back and forth between plus and minus signs. You could also see it written in a following way. Say n from 1 to infinity, cosine of n pi over n. Now cosine of n pi goes minus 1, 1, minus 1, 1, so this works with the alternating series concept. This would start with minus 1 plus 1/2 minus 1/3, and so on. Something that's not alternating is something like sum n from 1 to infinity sine of, say, n pi over 4 over n squared. Right, this is not alternating because it doesn't always go plus, minus, plus, minus. If we draw the unit circle here, we're going to have a value every pi over 4 in terms of our numerator value. So we'll get a root 2 over 2 here, then a 1, then root 2 over 2, and a 0. We're looking at the y-coordinate. Then negative, 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 0. So it'll be plus, plus, plus 0, minus, minus, minus 0, which does not go plus, minus, plus, minus. This is not an alternating series. There are some examples of what those might look like. So why do I care so much about a series being alternating? The point is, if a series is alternating, we have this nice alternating series test to determine if a series converges. And it must actually be alternating plus 1, plus, minus for this to work. So we're going to assume that our sequence Bn here is positive, decreasing, and converges to 0. i.e. every single term is positive, every term is less equal to 1 before it, and the limit is 0. So if I assume just those three conditions, I get that this alternating series converges. And that's all I need. If I take a sequence that is positive, decreasing, and converges to 0, then if I form the alternating series with those terms, I get that it converges. For free. No more work than that's all I have to do to show that it converges. Furthermore, if S is the sum of this series, then I can tell you some idea of where it is. If S is the sum, then I know that it's between 0 and the first term, and that's why I made the n minus 1 up here, was so my first term comes in positive. So I know this is the case. And furthermore, I also know that my sum is between SQ and SP, where these are partial sums, so long as P is even and Q is odd. We'll talk about why these are true in a future video. But the point here is this statement right here. If I have any series that's alternating, I must first determine that it's alternating. If it's alternating and then the terms of the sequence that make them all positive are positive, decreasing, going to 0, then it converges. No more work than that. I just get the fact out that it converges. And that's why we care so much about the alternating series, because they're really easy to talk about in terms of convergence. So now let's look at this series of -1 to the n over n. Does this converge? So we see right away this is an alternating series, with Bn being the sequence 1 over n. We're missing a minus sign in there, but we'll see how that factors in here in a second. But the sequence Bn is positive, Bn is decreasing, increase the denominator, the function gets smaller, and the limit as n goes to infinity of Bn equals 0. Therefore, by the alternating series test, this series converges. That's all we have to show. We show it's decreasing, greater than 0, and the limit goes to 0. Then since it's the alternating series, I get that this must converge. As another note, since we know that this series of absolute values is just 1 over n, this diverges. This becomes our first actual example of a conditionally convergent sequence. It converges by the alternating series test, but the absolute value series does not converge. What can I say about this limit? Well, the easy answer is the fact that I know it was between 0 and the first term, so I know that s must be between 0 and -1, and here's where that minus sign comes into play. Since my first term is negative, I have to put a minus sign here to flip this over here. I know the sum is in here, and I could sort of do more steps, but if I added one more to that, the next term, I would know that my sum is between -1 and -1/2, because that is the sum of the first terms in the series. And I can keep working this further on if I want, but the important fact is something like this that we know comes out of this result. So that's the idea of the alternating series test. The fact that I only have to prove a couple small facts that my series has nice properties, and then I get basically for free that it converges. And that's why we care so much about alternating series, because they are easy to talk about in the sense of trying to prove that series converge, and potentially they converge conditionally depending on what happens to the absolute value of that series.